Problem 16, section 1.8. We are told that f and g are continuous functions. F at 0 is 3 and limit x approaching 0, fx times gx is 6. Find g at 0. Alright, so notice if f and g are continuous, what does it mean? The limit x approaching 0 of fx should be the value at 0. Likewise, the limit x approaching 0 of gx must be the value of g of 0. So, we know that the value of f at 0 is 3 and we know that f is continuous. So, that is limit x approaching 0 of fx has to be the same as the value, that is 3. Likewise, now you are told that limit x approaching 0 of fx gx is 6. So when you take limit of a product, it becomes product of limits. We know that this is 3, we just saw, and this we don't know yet. Well, divide both sides by 3. So now you get limit x approaching 0 of gx is 2. What do we know? G is continuous. So limit has to be equal to value. So value is 2. Value of g at 0 is 2. Next problem. Use continuity to evaluate. Well, you have f plus 5 square root x, that's a continuous function on its domain. Square root 5 plus x, that is a continuous function on its domain. Continuous over continuous is continuous as long as the denominator does not go to 0. So, because this quotient is continuous, how do I find the limit? Just plug in 4. 5 plus square root 4 is 2. 5 plus 2 is 7 over square root 5 plus 4. Square root 9 is a 3. Next problem. Sin x is continuous. X is continuous. So x plus sin x is continuous. Sine of this guy is continuous because that's composition of continuous functions. So you are going to use continuity. In other words, plug in pi. So sine of pi is 0. So what's happening? Sine of pi plus sine of pi, right? X is going to be replaced by pi. But notice sine of pi is 0. Well, pi plus 0 is pi. Sine of pi, we just said, was 0. Next problem. Use continuity. Well, arctan is continuous on its domain. Rational function is continuous on its domain. You want to find the limit. Now, this is the catch. When I plug in 2, I get 4 minus 4, 0 upstairs, and 3 times 4, 12, minus 6 times 2, 12, 0 downstairs. So this has to be reduced. X squared minus 4 over 3x squared minus 6x. Factor and factor. You can cancel these two as long as x is not 2. So arctan of x plus 2 over 3x. Now I want to let x approach 2. So 2 plus 2 is 4. 3 times 2 is 6. So arctan of 4 over 6. Good. Next problem. If f is continuous, then absolute value f is also continuous. But if absolute value is continuous, then can you say that f is continuous? Not true. Okay. Answer is no. Let's see. Here is my f. So notice my function is piecewise defined. 0 onwards it takes height 2, to the left of 0 it takes height -2. So this is not continuous. But look at the absolute value f. What happened here? All the negative heights became positive. So all this negative height became positive because of absolute value. So absolute value is very well continuous, but f is not continuous. All right, so that completes our section 1.8 on continuity. Notice we have continuity intermediate value theorem also in section 1.8. So next videos will cover continuity intermediate value theorem. Okay, until then.